There it is, great. So, once again, thank you very much for inviting me to give this talk. And I think we left off when I said it's important to know how low is low enough for WHO, for air quality guidelines, but also for regulators. How low do we need to go to adequately protect our population? Next slide. So first of all, we need to define what are low levels. What do we define as low levels? And here you see an exposure response function from a very recent publication that goes from pretty much around 0 to 80 micrograms per cubic meter for PM2.5 and hazard ratio for mortality. And you see that it goes pretty straight up almost to high levels. These high levels we see predominantly in the mega cities of the developing world. But now we're interested about what happens at the lower end of this exposure response curve. And the question is, where do we draw the line here? Next, please. And so one possibility is that we say, okay, we define low levels as levels below the current air quality directives or below the US EPA standard, or next one, please. We can also define low levels below the WHO air quality guideline. Next one. So this is, for practical purposes of this talk, this is what I define as low levels of air pollution. Next one. Now, why is it important to look at these levels? Of course, large parts of the population in large parts of the air of the world are exposed to these low levels. And here's an example, is the exposure to background NO2 air pollution in Germany. And you see on the right side the current EU limit value at 40 micrograms per cubic meter. And then you see the parts of the population that are exposed to long-term levels of NO2, and the peak of the population is quite below the current EU limit value for the background NO2 exposure. Now, looking at potential exposure response functions, this is would be a linear one where we say, okay, it goes down to potentially 0 in a linear fashion, or the exposure response function could look similar to this, so it could have a threshold somewhere, which would be a very good motivation to put the limit value somewhere where the threshold lies. Or it could have a form like this, which would mean in our regulation we need to be we should define a very different limit value. And you can imagine these different forms of the exposure response functions. They have a huge impact on burden of disease, and therefore will have a huge impact on on the prevention of non-communicable disease in these populations. So that's why it's really important to find out more about the form of the exposure response curve in that part of the function. So what are the challenges to study this? First of all, if you go down to these low levels of air pollution, you need really large studies with potentially millions of participants to be able to detect an effect. And you also need very detailed information on socioeconomic and lifestyle variables to take care of potential confounding with other variables. Thirdly, you need obviously an excellent exposure assessment to be able to detect effects at these low levels. And you also need effects on concurrent exposures, because ideally you want to tease apart the effect of different air pollutants and of different exposures, so you can then formulate adequate preventive actions. Now, if you want to go to low levels of air pollution, one good place to study this would be Canada, because that's generally not known for extremely high levels of air pollution. So there's one study that I would like to show you from that was published in 2016, the Canadian Community Health Survey Cohort. It's already quite a large study on 300,000 adults, and they had a very good exposure assessment using different modes of different techniques with satellite measurements and chemistry transport models and land use monitoring, and were able to estimate exposure at a 1 by 1 kilometer surface. They also had very detailed individual data on smoking and other personal risk factors, including socioeconomic status, and they also had very good information on several large-level socioeconomic covariates. And this is what they found. And you see on the x-axis the PM2.5 concentration and the WHO air quality guideline at 10. And you see that left of this, so at an area where we think we should actually not see strong effects anymore, you see an almost linear dose-response relationship. And if you look at the size of this effect, the hazard rate here was 1.26, which means per 10 micrograms per cubic meter PM2.5, you get a 26% increase in mortality, which is actually huge. If you compare that to what the WHO Rapier project in 2013 suggested, they recommended an increase in 6% for burden of disease assessments. So this is actually a huge effect that would have a huge impact on calculated burden of disease. Now, in the Canadian study, they did not have information on concurrent exposures. So here's another study in the Netherlands that has information on PM2.5 and NO2. And of course, it's important to be able to tease apart as much as possible these two effects. And they actually saw linear dose-response relationships for both pollutants below the current EU limit value. And if they adjusted for each other, next please, next one, the effects that they saw, they were sustained even when they adjusted for co-pollutants. Next one, please. So the largest study up to date now is a study from the US, where they actually looked at 61 million Medicare beneficiaries, and they had exposure on a very small surface scale, 1 by 1 kilometer, for PM2.5 and ozone, using a combination of different techniques. They also had data on personal lifestyle variables in a subsample of their 61 million. The subsample was 57,000 people, so it's still enough to have a good evaluation. And these personal covariates, they were actually very lowly correlated with air pollution. So it is not likely that the results were confounded strongly by these variables. So what did they see? On the exposure response function here goes down to about 5 micrograms per cubic meter for PM2.5, and they see an almost linear and extremely precisely estimated exposure response function. And if you look at just the exposure response below 12 microgram, which is the current US EPA standard, they showed an increase in mortality by 14%, which is way larger than what we are currently using in our burden of disease assessments. Next one. Now, so far we talked about mortality, and of course it's also interesting to look at at the incidence of non-communicable diseases. And here I want to show you an ongoing study, Effects of Low-Level Air Pollution, a study in Europe, where we are pooling results, where we're pooling cohorts from, I think, 10 different cohorts across Europe with almost 400,000 subjects with very detailed individual level information. And we also analyze 35 million subjects from administrative and national cohorts. And in these studies, we look at the incidence of cancer and cardiovascular events, myocardial infarction, stroke. And in principle, there's the possibility to extend this to other outcomes like diabetes, cognition, and other non-communicable diseases. This study is ongoing, and we expect the results by 2019, hopefully in time before Europe decides whether it's going to revise its air quality guidelines. So next one. So the key messages of the studies on low-level air pollution is they have, I mean, the form of the exposure response function has a potentially very large impact on burden of disease in many areas of the world. Many important health outcomes are still understudied, specifically at these low air pollution concentrations, which result in a huge preventive potential if we can actually lower our air pollution, even if we are already at levels below current standards. So this has a large regulatory impact, first of all, of course, for the WHO air quality guidelines, which are currently under revision. But also in other parts of the world, EPA is currently revising its PM, Integrated Science Assessment, and the Ozone Integrated Science Assessment is under development. And of course, as already said, currently ongoing in the EU, we have the Air Quality Directive fitness check, which will hopefully result in a conclusion that the current European air quality standards are not low enough to adequately protect the European population. Thank you very much.